I am standing in for M. Connor again today. And it looks like we have one demo for today. Jeff is going to be telling us how to integrate with Mozilla's data infrastructure. So Jeff, I will hand it over to you.
Thanks, Rachel. All right, can you see my slides? All right. So I'm Jeff Klukas. I work on a team that builds what has been traditionally called the telemetry data pipeline. So the big thing that flows through here is all those Firefox clients out there sending payloads that this pipeline receives, and we store them, and people do analysis on them. It's great. So that word telemetry really means recording something that's out there in the world. It generally refers to, in the software context, clients. So Firefox desktop, the mobile clients, that's kind of the bread and butter of the telemetry data pipeline. But it's not just for telemetry anymore. We have had really, this pipeline has existed for several years. It's gone through a lot of iterations, and it has evolved to become more general and serve more needs than just telemetry. So there are various use cases that already exist kind of internally in Mozilla. Bugzilla sends information through the data pipeline. Last year we had success in taking the activity stream pipeline, which that's the new tab page in desktop Firefox, had its own data pipeline that it sent custom payloads to, and we were able to successfully transition that to use our core data pipeline that we use for telemetry as well. And there's work going on this year to take Firefox accounts, which has its own metrics pipeline as well, transition that on. So a big piece of this talk is just letting you know that we have this data pipeline that really is intended at this point to serve Mozilla needs broadly, and it is something that is possible to integrate with. The real call to action from this, I'm going to repeat this at the end of the talk as well, is if this topic has piqued your interest at all, go take a look at docs.telemetry.mozilla.org. And in particular, there's this article, Guiding Principles for Data Infrastructure. So there are other pieces of the documentation that describe in detail exactly how the pipeline works. There are pieces that talk about exactly how to interact with it, make queries for various needs, what data sets exist. But this particular section of the docs, Guiding Principles for Data Infrastructure, really kind of talks about why is the pipeline set up the way that it is? How do you even go about thinking about how to make a data infrastructure? What are the pieces that are important? So one of the things you'll learn in there is we talk a bit about what are the big data components in Google Cloud Platform that we've chosen to build the pipeline on top of, and why might you also want to use these things as primitives if you are building something that looks like a data pipeline. The biggest one is BigQuery, which many of you interact with on a daily basis, either through Redash or making queries in the BigQuery console directly. But BigQuery is really our data warehouse at this point, and it has some really nice properties for interacting across an organization. So even if you aren't using our data pipeline, if you have some other data set that you get into BigQuery, part of what's really nice is integration of access model, so that if you need to join some data set that you've produced, it's in your own project, you have ownership of it, you have governance over that data. It's possible to write queries that join that data in one place in GCP with data in a completely different project in GCP. So it's possible to take telemetry data, join it with other data sets, and there are data access models for handling permissions in those various projects, defining who's allowed to query what. So it makes a much easier story for integration across teams than if we have data sitting in various data warehouses or data stores. The other two components listed here are primitives that you can use if you are doing streaming of some sort, or if you want to do compute. So data flow is really a platform for doing computing on data-intensive applications, both in streaming or in batch mode. There are parts of our data pipeline that are defined as cloud data flow jobs, and that is something that we have some operational experience with, and it's something that we can help you understand how to do if that's something that makes sense for other applications that you want to build. Cloud pub sub is kind of the counterpoint. BigQuery is this data warehouse where you keep historical data. Cloud pub sub is kind of the data store for streaming data that Google provides. And if you want, there are various ways that you can integrate with our data platform. Get telemetry data, we can provision a topic that has just the subset of telemetry data that you need to serve some streaming use case. This is something that Pocket uses. They take a subset of the telemetry that's flowing through the system, and they're able to make decisions in near real time based on that client data that's flowing through. So again, that article has more context on what are these technologies, how are they useful, how do you integrate with them, and how can you use these things to integrate with data that's actually in our data platform. Other big point of this, really the rest of this talk, is convincing you that you probably should not build a custom data pipeline. Use ours, or at least talk to us about how you might want to integrate with the data pipeline rather than creating something on your own. So I'll give a brief overview of what it looks like to define some new type of payload that you want to send through the data pipeline, what it looks like to query it in BigQuery, and then I'll finally talk about some of the concerns that are solved in this pipeline that are things that you have to handle on your own if you're going to build something custom. So the basic flow of how you get data into our pipeline is you define a schema. Defining a schema really defines how data flows through the pipeline and where does that end up in BigQuery, and then you start sending data that matches that schema. So defining a schema looks like making a pull request to this particular repository. So the name of the repository is Mozilla Pipeline Schemas, and it's basically a set of JSON schema files that define these various payloads that flow through our system. So this is a real-world case of somebody outside of the data platform team or the data engineering team contributing a new payload type so that activity stream can send data through our pipeline. So Nan is an engineer that was working on what was the activity stream team at the time, and various responsibilities have shifted since then. But he made this PR. JSON schema is this standard language. You can find lots of documentation about how to write it out on the internet. But kind of at a high level, it's basically we're listing a series of fields. So we have a field here named add-on version. The type of that is a string. We have another field block with a description, and the type is integer. So this gives us all the information we need to validate payloads that are sent to the pipeline, and also to define a table for these payloads to live in BigQuery. So if you make this PR, we will review it. We can give lots of information and advice about what the implications of making various choices about how you express things in a schema, what effect that will have in terms of the BigQuery table that's generated, etc. So once you make that PR, it gets integrated. Within a day, there's a whole process that kicks off where your schema now becomes a table or a series of tables in BigQuery. And you can see on the last slide, we saw there was this add-on version field that was defined as a string in the JSON schema. It translates right into an add-on version field that's a string in the BigQuery schema. So there's now a table where this data is going to land as it flows through the pipeline, and the last piece is actually sending the data. So sending data to our pipeline looks like JSON payloads sent to a URL that is publicly accessible. So the JSON document shown in the box there, again, you can see this add-on version field. That's a string 1.7.12, various other fields in there. This is going to end up as a row in BigQuery. And that document is sent to this particular URL. It's always incoming.telemetry.mozilla.org. And then further down in the URI, you have the document namespace, document type, and document version. Those all correspond exactly to where the schema is defined in that Mozilla Pipeline Schemas repository. And then finally, there's this document identifier, which is something that the client needs to generate with every message that it sends, and we use that for deduplication. So if a client sends a message multiple times and gets an ambiguous response for the pipeline, et cetera, and so it's resending, we're able to take care of deduplicating that. So what we show in BigQuery is only one copy of that message. So this is a fairly generic interface. It involves some engineering effort of setting up that JSON schema in the first place. There's some engineering effort in terms of having to send to this URL and handle the HTTP requests, etc. But it is totally feasible, and it's pretty generic, so that you can use this for a wide variety of use cases. Before we finish, I want to really talk about some of the features that are baked in here that may not be obvious, and maybe things that you really want to care about if you're building a data pipeline. The first is schema validation and error handling. Is that as messages flow through here, when they hit the pipeline, we check that they actually match the schema that has been defined. If they don't match it, we don't just throw the message away. We throw it into a well-defined place in BigQuery so that we can review that, and we do regular pipeline review to see if there are error cases where we're seeing a lot of messages being rejected. We'll file bugs. We'll follow up with people about figuring out what's going on with those, and we can backfill rejected documents if we find that there's some adjustment that needs to be made to the schema, etc. There's a lot of monitoring that we do. There's deduplication, as I mentioned, of clients that send the same message multiple times. We're able to filter those out so that you don't have to worry about that when you get to the analysis level. And finally, we have tooling for ETL and for doing backfills. So ETL is extract, transform, load, basically creating derived tables based on the raw data that is flowing through. So we have this whole repository, BigQuery ETL, where you define SQL queries that create these derived tables for you. And again, we can provide you with assistance in figuring out how to make that part of it happen as well. Finally, I need to mention that it can get even better than this. If you've not heard of the Gleen project, it's the state-of-the-art for metrics collection. It really takes that process of creating a JSON schema. It lets you work at a higher level than that, where your application, instead of having to define that JSON schema and having to send HTTP payloads, this library lets you define higher level metrics, and then it generates an API that you can use in your application to send logical metrics, and then it handles batching those up and doing the sending of the payload that's correctly formatted in the background for you. So you really don't have to worry about the specifics of making sure that your payload is structured exactly a certain way and worrying about the details of how do you write a JSON schema. So yeah, thank you for your time. Again, the big thing I want you to take away is if you're interested in some of these concerns, take a look at this guiding principles document in docs.tmo, and FX metrics in Slack is where to find my team and a lot of the related kind of data users. And we would love to hear feedback, questions. It's a great place to get started in figuring out how are you going to integrate with the pipeline.